Hi, multiplication fact strategy teachers. Today we're going to talk just a little bit more about the splitting strategy. So yesterday when we looked at the splitting strategy, the strategy where students split apart or decompose or break apart an unknown multiplication fact into two smaller benchmark facts they do know, we always split the unknown fact into two equal facts. So two facts that were the same size. And as a convention in University Place School District, that is how we teach students to use the splitting strategy, that they split it into two equal benchmark facts, two benchmark facts that are the same. However, we know, as adults who understand multiplication, that you really can decompose a rectangle or decompose a multiplication fact in a number of ways, and they don't always have to be two equal rectangles. So I tell you all that to tell you that it can be really helpful to teach your students to split unknown 7s facts into a 2s fact and a 5s fact. And so we're going to look at that here today. Now, this is only a strategy that you would even teach your kids if you were feeling really confident with the splitting strategy and your students were feeling confident with it. And you're finding that they're really having a difficult time with 7s facts. 7s facts are really stumping them. They're having a hard time maybe using the other factor. 7 times 7 is really a sticking point for them. This is not something you have to teach. It's an option if you're feeling ready for it. So let's take a look at the fact 7 times 3. If a student didn't know 7 times 3, they could split the 7s fact into a 2s fact and a 5s fact. They could split that factor of 7 into a 2 and a 5. So just like when we were splitting 8s and 4s in our previous video, we show that we're decomposing the 7 with a number bond, and we would talk to students about how 2 and 5 are parts of 7. We're able to decompose a 7s fact into a 2s fact and a 5s fact because 2 and 5 are parts of 7. And the reason that we would want to do this is because we know our 2s facts. If 2 was one of the factors in a benchmark, we would know it. We know all of our 2s facts. And if 5 were a factor in one of our benchmark facts, we would know that as well. We know our 2s facts and our 5s facts really well. Of course, if we split the 7 into a 2 and a 5, the factor of 3 stays the same. It becomes our common factor. So both of our benchmark facts are going to have that common factor of 3. We are decomposing our new fact, 7 times 3, into two smaller benchmark facts, and we're ultimately going to add them together. So as you've seen before, I have kind of a framework here for our expression. And if your students, when you're kind of first reintroducing this to students, it can be helpful to either provide the framework for them for the two separate equations that they're going to add together, or to even just teach them to kind of draw the framework first before they fill it out. That can help students too. Also, when you're moving away from splitting into equal size groups, if you decide to go ahead and teach kids to split 2 and 5, it can be helpful to reintroduce an area model or show them a couple of problems with an area model, just so that they can see that you really are breaking apart this 7s fact. You're breaking apart this multiplication fact into two smaller facts that are not the same size. One of them really has a factor of 2 and one of them really has a factor of 5. So here is where you are going to have to really do some explaining and really explain that distributive property, and also really look at an area model and see why things are happening. So because we've split the 7 into a 2 and a 5, our two benchmark facts are not going to be the same. We're going to distribute the 2 from the 7, when we split the 7 into a 2 and a 5, the 2 into one of the facts and the 5 into the other fact. The common factor, 3, is of course going to be in both benchmark facts. It's a common factor. It's in both benchmark facts and the new fact. So we now have two benchmark facts, 2 times 3 and 5 times 3, that we need to add together to find our new fact of 7 times 3. And again, bringing it back, especially for students, at least modeling a couple or showing a couple of problems with an area model and seeing how we have actually broken the 7 by 2 into a 2 by 3 rectangle and a 5 by 3 rectangle. We have broken it into two different multiplication facts, but when we put them together, they clearly still cover the same amount of space. So once students have their two benchmark facts, 2 times 3 and 5 times 3, they'll know that 2 times 3 is 6 and 5 times 3 is 15. They'll add those together for a total of 21. And of course, that means that 2 times 3 plus 5 times 3 equals 21, and 7 times 3 equals 21. We'll go ahead and look at one more example together. 7 times 7 can really be a sticking point for students because there really is not another strategy, more area compare, less area compare, that works for 7 times 3 because the available benchmark facts generally aren't helpful. Students who don't know 7 times 7 also probably don't know 6 times 7 or 8 times 7. So, should you choose to teach students how to split sevens into a 2 and a 5, it might look like this. If we didn't know 7 times 7, we could split one of our 7s into a 2 and a 5 because 2 and 5 are parts of 7, and we know all of our 2's facts and our 5's facts. The other factor, which is the other 7, we didn't split, so it will stay the same. That's going to be the common factor. So then we're going to end up with 2 multiplication facts, 2 benchmark facts. 2 times 7, my first factor from splitting the 7, 2, times the common factor 7. And I'm going to add that to my other fact, 5, from when we split the 7 into a 2 and a 5, 5 times the common factor 7. And all of that together will equal our new fact, 7 times 7. Of course, students know their 2's facts and their 5's facts, so they know that 2 times 7 is 14, and 5 times 7 is 35. And when they add those together, they're going to equal 49. So 7 times 7 equals 49. Thanks so much for splitting sevens with me. Have a great day.